and we will get things underway with Tucker. Thank you.
Okay. Thanks, everyone. Let's get started here. So today we're going to talk about TR-181, the data model, both for TR-69 and USP. So basically, we're going to cover, a little overview of TR-69, touch on USP a bit, and then the data model itself, and in particular, how to effectively test that data model through, even if it's customized or, sort of what you can do to get the most out of your testing when it comes to your device, and how you can use CDRouter to do the most in that department. So before we start talking about data models, I just wanted to touch on the two protocols we're talking about. So that's TR-69 and USP. So I think a lot of people have a sense of sort of what these two things are, but I just want to make sure we get an overview here. So both are remote management protocols, and they allow for the remote configuration, monitoring, and diagnostics of deployed devices. So devices that are out on the field. On the TR-69 front, TR-69, also commonly called CWMP, that's, for if you really want to spell it out, the CPU WAN management protocol. The way it works is a CPE out in the field will send an HTTP post to an ACS, or auto configuration server, and the ACS will send a response, which is, like an RPC saying, hey, can you get or set a parameter, or add or delete objects. There's a few other, you can do reboots and install DU units, but that's, just extra stuff. And then the managed device will send another post with the outcome. So, the full exchange looks like a CPE sends a post saying, hey, ACS, do you need me to do anything? The ACS will send a response saying, hey, can you give me the value of this parameter? And the CPE will then send another post saying, yep, here's that value. The downsides of TR-69 is that it's not all that easy to get a managed device's attention. Because this is all sort of HTTP based, traditionally you just do what's a connection request, where the ACS directly sends a HTTP GET to some connection request endpoint on the CPE. But, because of varying network configurations, that often just isn't possible. And so there's a couple solutions for that. The real common one is using XMPP, which is sort of the chat server protocol. So basically, the CPE would join a chat room, and the ACS would then, using the XMPP server, poke the CPE saying, hey, can you reach out to me? And then the CPE would then send that HTTP post saying, okay, what do you need? The even older way of doing this was stun. However, TR-69 only supports classic stun, which is deprecated. And, as even the spec says, you should use XMPP instead. The other downside of TR-69 is that it only supports a single ACS, which means that there's only one server that can control a device at any given time, which sort of cuts out a lot of use cases for managing a device. You can't have multiple organizations interested in parameters or values set on a device. Or if you do, you have to go through a single server. So, there's some coordination on that side that adds a lot of complexity. And the overall protocol is sort of inefficient. As we said, there's this whole process of getting a device's attention that's out of band. It's all done over HTTP. And inside of that are these SOAP messages, which are all XML. And, if you want any sort of security, you're going to have to go through you use HTTPS. So there's the whole TLS handshake every single time you want to have a session. And the connections, the sessions are, they're HTTP sessions. So it's not an always on connection, which means, every single time you want to exchange some messages, you have to go through this whole process of reaching out, getting the device's attention, setting up a TLS connection, and then actually exchanging the few, parameters that you want. So on the other side, there's USP, which is the newer protocol that is sort of the lessons learned from TR-69. How can we make this better? And so first and foremost, USP supports multiple controllers with varying permissions, which is fantastic if you have some third party that's only interested in collecting a couple of statistics. You can give them, an agent. You can point the agent at a controller owned by them to just collect a few stats and only give their controller permission to read those couple of statistics, things along those lines. All communication over USP is done over the same transport protocol. So there is no out of band, there's no XMPP connection request. There's no stun or anything like that. Once you have a connection, it's always on, which means that, like I said, no more connection requests. And to support all the use cases that USP provides, there's 3 transport protocols, WebSockets, Stomp, and MQTT, which provides people a lot of flexibility. All 3 of these protocols have, really sound, mature libraries around them. And they also provide multiple layers of encryption. So at the MTP layer, or the message transport layer, or the WebSocket, Stomp, or MQTT layer, it's all the same thing. You can encrypt there, or actually within USP itself, you can have encryption. So there's just a whole lot more security you can cook into USP messages going back and forth. And with that always on layer, there is no delay. There's no need to get a device's attention. So there's a lot of improvements that way. And on top of all of that, the messages exchanged going back and forth are really efficiently encoded using Google's protobuf encoding, which is much more compact than something like SOAP messages. So you might think, okay, well, that's great, but it doesn't really make sense to talk about these devices, or make sense to talk to these devices unless there is something to say. And for that, you need a data model. So what is a data model? And it's an agreed upon collection of objects, parameters, and in the case of USP, events and commands. So for example, and you might have a object table that's full of firmware images, which in the TR-181 data model, that's device.deviceInfo.firmware image. And then each object in that table might have a name, a version, and a status. So to go a little bit further, today mostly we're going to focus on TR-181, which was first published in 2010. Issue 2 was published in May of that year. Actually, issue 1 was published in February of that same year, but we're not going to talk about issue 1. And TR-181 is pretty much the most modern version of the broadband forum data model. Any modern TR-69 device or a USP device should be using TR-181. And in the case of USP, you don't really have any options. There are some older options for TR-69, which you do encounter sometimes, but we're going to focus on 181 for today. So you might be wondering, why should I implement an existing data model? I could just, I have a sense of what I want my device to do. I could just cobble together sort of my own parameters, and I wouldn't have to keep referring to this standard. And one of the answers is, well, the documentation's already written. Sort of how these parameters should be structured, or at least a good way to structure these parameters, has already been come up with. And on top of that, the parameters you might want to implement, there's already documentation around that. And it also means it's a unified way of interacting with the device. So, you're abstracting the device specifics away to the data model itself, which is very handy for if you have a device made by one vendor, passing it off to another. All you have to do is go to the Broadband Forum website and look at the data model and figure out how to talk to the device instead of having to look for a manual, right? And so, okay, you thought this is starting to sound good, but which parameters should I implement? And maybe instead of focusing on parameters, the better thing to do is to think about profiles. And so profiles are subsets of the whole data model, which target specific functionality. So for example, this is from the 181 data model, as you can guess. This is the packet capture diagnostics profile, which is fairly new. And so this provides some packet capture functionality. So if you wanted to implement, the packet capture diagnostics part of the data model, implementing these, let's see, what do we have here? 5 parameters and 2 objects would be a fantastic start. Okay, I hope at this point, you have sort of a sense of TR-069 and USP and the data models. And you're starting to think, okay, fine, I'll implement them. And so you've implemented TR-181, or at least the profiles you want. But now what? And the answer is probably should test them. So CDRouter can make profile testing very easy, or data model testing rather. And that's through 2 methods. There's profile testing, and there's also functional testing. So profile testing with CDRouter, you can verify that all the expected parameters and objects exist on a device. And that means, doing a get, or a get parameter values, or a get supported data model, or get parameter names, depending on whether you're talking about USP or TR-069. You can verify that all of the parameters in a profile have the expected data type. And that can be done by looking at the data type for the actual XML element in the SOAP objects in TR-069, or by looking at the reported data types from the get supported data model message in USP. Verifying that all of the parameters have the expected read and write access. And in fact, that parameters that should be writable can be written to, that, when you actually try to write to these parameters, you don't get an error back. And also that objects that you should be able to create and delete can in fact be created and deleted. So in TR-069, within CDRouter, we have these profile tests, right? And so for each profile, there's 7 test types. There's the get parameter names from the top level of the profile, which means whatever the sort of root object is within that profile, we do a GPN, a get parameter names from that top level, and verify that all of the parameters returned, or all the parameters within that profile are within the response from the CPE. There's also the get parameter names where we walk each level. So a lot of these profiles have numerous objects within them. And so doing a get parameter names on each level, it can sort of make sure that devices return all of the expected parameters at every level. That's something that we've actually run into in the past is devices that if you do a get parameter names or get parameter value at the sort of local object for one of the objects in its data model, it will return all of the parameters. But if you go a few layers up, sometimes some parameters are missing and don't get included, or vice versa, right? If you do a get at a top level, it will give you the sort of the full tree, but then once you actually get down and do a get at the individual object level or on a specific object, parameters will be missing. So this test is a great way to verify that there's no problems there. Then there's get parameter names, and that the verifying the write access. So within all of these profiles, they're all labeled whether or not they should be read-only or whether or not you should be able to write them. And so this test does a get parameter names and looks at all of the writable flags on all of the parameters returned and verifies that there's no mismatch for parameters that should be writable that according to the DUT they're not, or vice versa. There's also, of course, just a get parameter values test, and that does a full get parameter values from the root of the profile and verify that all of the parameters that are expected are returned. And furthermore, for parameters within profiles that have some syntax, so you can imagine a string value that has a minimum and maximum length, or a enum value that the data model says this parameter can only be one of these two values, like a light bulb, it can only be off or on, right? The get parameter values test, a part of that will verify that the values returned by the DUT are in fact, they conform to the syntax defined by the data model. So, if for enums, make sure that one of the, the value returned by the device is a valid enum value, or that strings are the right length, that the types for those values, such as a value that should be an unsigned int according to the data model is in fact an unsigned int. Things like that are done by this test. There's also the set parameter values. So what this test will do is do a full get, just like the above test, but then for all of the parameters that are deemed writable by the data model, we will try to write the value we just read right back to the device. And so the goal there is hopefully, one, not to change the state of the DUT, because we don't want to just blindly be writing values, but if we just write the exact same value right back, we should get a sense of whether or not those parameters are writable. So what we look for there is when we write all of the allegedly writable parameters back to the device, that the device just returns an okay and doesn't have any errors. It doesn't say, hey, that's not a writable parameter. And lastly, or not lastly, then there's the add and delete object test. And so what this does is objects that should be creatable or deletable, we will create an instance of all those objects and then delete them and make sure that is error-free. And now lastly, they get parameter values on all GPN full paths. So this test is sort of a multi-RPC test where we'll actually do a get parameter names on the root of the profile. And then we'll walk through and do a get parameter values on every single parameter that was returned. And so, as I said before, sometimes we've seen devices have some issues where, depending on where you're doing a get from, some parameter values will be missing. This test can really help pin down or identify issues like that, where get parameter names might report that a parameter exists, but then you go do a get and your device returns an error saying, I don't know what parameter you're talking about. So those are the 7 tests for for TR-69. On the USP side, there are 5 test types, and I'll go through these a little bit quicker because they're very, very similar to the TR-69 versions. And so there's a get supported data model, which verifies the presence of the parameters, very similar to the get parameter names from the top level of the profile. There's also the get supported data model test for verifying write access. So similar to the 3rd test from the previous slide, we go through and make sure that all of the parameters that, according to the data model, should be writable are indeed writable according to the get supported data model response from the device. There's, of course, the get test, make sure all those parameters exist. In the case of USP, all of the get response messages, all of the parameter values are through protobuf encoded as strings, which means we don't have quite the same ability to look at the sort of reported types. On the TR-69 side, there is the type encoded into XML. On USP, it's just their strings. However, we do still verify that syntax. So make sure that enum values are within the expected enum. Make sure that unsigned ints look like unsigned ints, things along those lines. And then the set test is very similar to identical basically to the set parameter values test of TR-69. That's just, we do a big get, and then for all of the writable parameters, we try to set them right back. And then the add and delete objects test. And so just like TR-69, we try to create an object and then delete it again and make sure that that is error-free. So specifically for TR-181, CDRouter has a lot of these profile tests built in. For TR-69, there is 1,158 profile tests. And the name of them is sort of structured as the data model, which, as we're saying, we're talking about issue 2 of TR-181. So it's device 2. And then underscore the profile. So as you can see in this image, we have VLAN termination, and then the test itself. So, now we can see the tests that I just went through, the GPN walk, the, GPV, the SPV, that, we're talking about set parameter values and get parameter values and get parameter names. On the USP side, there's, slightly less tests because, like I said, there's, 7 profile tests on the TR-69 side. There's only 5 on the USP side. They're structured a little bit differently. They have USP underscore at the front of them. And so now you can see this is the exact same profile in the device 2 data model, but for USP. So we've got USP underscore device 2, VLAN termination, that's the profile, and then the 5 tests. And it's also maybe worth noting here, just for anyone that does any business with RDK, We also have 87 RDK profile tests on the TR-69 side and 61 RDK profile tests for USP. So those are just a handful of profile tests that we've concocted out of the RDK data model. Now, this is all good, and you might go home and have this all set up and realize that, hey, wait a second here, my device is failing these couple profile tests, and realize that, wait a second, this parameter, according to the data model, it should be read-only, but I wanted it to be writable. This isn't a bug on my device. This is intentional. And yep, that happens. Sometimes these profiles, you just want to tweak them. And so for that, you can customize. So, like I said, sometimes you want to, modify the write access. Sometimes you want to tweak the parameter syntax. Who knows? Maybe it turns out that the minimal length for a string for one of the parameters in your data model is far too short. And you want the minimal length to be larger, or you want to tweak the syntax one way or another, or you want to make a parameter optional, or perhaps you want to skip a parameter entirely. Well, these things are all possible. First, let's talk about profile modifications. So for TR-69, you can modify a profile using the CWMP modify parameters test var. So just like so, this line is we're modifying the NTP server 1 parameter. And basically we're just saying this is read-only now, and its max length is 64. Now, the specific syntax here, you can find out more on the user guide, which is going to be linked at the end of this presentation. But I think this gives a good example. On the USP side, it's basically going to be perfectly symmetric to the CWMP side of things. So the test var is USP modify parameters, and you can do the exact same thing. So that makes it really easy. If you have a TR-69 data model that you're porting over to USP, which means you've got the same set of tweaks that you need to port over, you for the most part should be able to just copy the CWMP modify parameters test var, make a copy of it, rename it USP modify parameters, and you should be up and running. Now, sometimes you just don't want to implement a parameter for one way or another, one reason or another. And in that case, the easiest thing to do is just to skip them. And so once again, on the TR-69 side, that can be done with the CWMP skip parameters test var. And so we've decided, what, let's just go ahead and skip that NTP server. We don't want anything to do with that. And so what that means is, and actually I'll just show you on the USP side, of course, it's the exact same thing, just instead of CWMP, we have USP. So what that means is now in all of those profile tests that we talked about earlier, all 1,150 whatever, and in the CWMP side and all 700 plus on the USP side, if any of those profiles have the device.time.ntp server 1 parameter required, or even optional as part of that profile, CDRouter will just completely ignore it. It could be included in any of the gets from your device. It could be excluded. It doesn't matter. CDRouter won't care, and you're not going to get, you won't fail a test because of that. So if you have parameters that you're missing that you will never implement, perhaps because you've implemented that functionality as a vendor specific parameter elsewhere, this is generally the best way to deal with that. Or maybe you have quite a few of these modifications, right? You've got several profiles that you've only partially implemented. You've got a lot of vendor-defined parameters. You have maybe lots of customizations to a parameter, or you've modified a lot of the syntax. Maybe the thing to do is to have CDRouter run these profile tests on a completely custom data model that you define. And that's totally possible. So let's talk a little bit more about that. So you can actually feed CDRouter a custom data model in the BBF TR-106 format. And what CDRouter will do was it'll treat that entire data model as sort of a single profile. And so just to quickly review that format, you've got a document and then your model, and inside that model there's objects and parameters with syntax elements and more objects. So it's not too bad. So what you'll do is you'll set up CDRouter to use one of these custom data models. And so you'll do that by, on the TR-069 side, creating a test var group. Here we have CWMP profile 1, pointing to sort of what we've called our profile name, which is kit 2. And then the CWMP profile path is a complete path to our custom data model on the CDRouter system. And, like I said, USP is pretty much identical to CWMP in terms of how it's implemented in CDRouter. That was by design. And so, if you want to do this on the USP side, it's the exact same thing. You'll just change CWMP to USP. Once those are configured, you'll create a package and add the custom profile tests, that package. For CWMP, these are the CWMP profile tests. It's a whole module. There's the 7 tests that we talked about earlier. For USP, the module is called USP data models, which once again has the 5 tests that we mentioned previously. And then you're off and running. CDRouter instart will parse that entire XML file and read it in just as though it was TR-181 from the BBF, and generate a test on the fly to verify all of the parameters in that custom data model you have. So it's pretty handy. But you might think to yourself, I don't have a data model for my device, or I do, but it's not in the TR-106 format. This is definitely an issue that people run into a lot. However, through some recent changes, we've added CDRouter, the auto profile, which uses RPCs in start to profile the device, and then creates an XML data model based on the reported parameters. And so what we're talking about here is in start, CDRouter will do a bunch of gets, both get supported data model on the USP side, or get parameter names and get parameter values on the TR-069 side, and look at all of these parameters reported by the DUT, and then build one of these XML data models and output it into the log directory of the test run results. The downside here, though, which I'm should definitely highlight, is that this should be used as a starting point, because if your device is missing parameters, or like I said, earlier, sometimes devices don't report parameters from some levels. So if you're doing a get from the top level, there might be some missing parameters down within several objects deep. Those parameters aren't going to get included in this data model that CDRouter generates. And further, it won't contain any syntax information, right? There's no way to get syntax information out using these RPCs. But to show you sort of how this looks, what you'll do is for those test vars, USP profile path and CWMP profile path, instead of setting those to a XML file on the CDRouter system, you'll instead just set those to auto. And you can actually run the CWMP or USP sort of custom profile tests in this mode. And it doesn't need to be a two-step process where you generate the XML and then run those profile tests. However, like I said, when those custom profile tests are run, it'll be using CDRouter's understanding of your device's data model, which might not be entirely accurate. It's only what your device reports. So if there are missing parameters, you probably won't catch that. So anyway, you've set this to auto mode, and then you run your test. And then in the test navigation side of your results, you can click on the little folder to check out your result directory. And then you should have an XML data model right there. So what I've shown here is the USP side, which the file is called USP extracted data model. On the TR-69 side, everyone can guess it. Instead of USP, it'll say CWMP extracted data model. So that is a very great way to get a leg up and sort of accelerate your the process of getting a data model up and running, especially if you have a new device that you've just gotten from a vendor or something along those lines, that you don't have one of these data model files, but the device has a lot of vendor defined parameters. So there is no real, pre-built profile tests that will be able to test all of it. This is a really good solution. So the other thing that I mentioned earlier on, in addition to profile tests, are functional tests, which I'm not going to go through in too much detail, but I did want to just touch on them. In the TR-69 side of things, CDRouter does have a lot of functional testing, which is, really excellent. We implement the full TP-181 test plan, which tests a huge amount of functionality within the 181 data model. There is also the TR-69 wireless module, which reconfigures the device, the wireless settings, and ensures that truly the radio actually broadcasts the updated SSIDs and the updated modes, and that a LAN client can connect to them using the new updated SSIDs. And then the TR-69 diagnostic tests, run all of the TR-69 diagnostics, and making sure that when you actually enable a diagnostic, the device reaches out and does download a file or uploads a file, things like that. And also TR-69 Annex N, which is the bulk data functionality. On USP side of things, it's a little bit lighter just because USP is a newer protocol. But of course, there is the USP conformance tests, which touch on more of the MTP specific and sort of USP protocol specific components of the data model, but still lots of that functionality. There is also the bulk data functionality tests, the Annex A module, which verifies that all of that bulk data functionality, just like TR-69's Annex N, works. And last but not least, this is the one final thing I wanted to mention in terms of functionality tests. Sometimes, you have some functionality on a device that you want to test, and there isn't a great test for it. And for that, sometimes the best way to do it is to use CDRouter scenarios. And scenarios is a simplified test case language that allows you to really easily create simple test cases that can do sets and gets and adds and deletes of objects, and verify that, as you're manipulating the state of your device, the correct things are happening. And further, you can actually use these scenarios in a sort of a bootstrap setting, so that as CDRouter starts up, your device gets configured the way that you expect for the tests. And then there's the full-on CWMP or USP scenarios tests, which are basically just our ability to write custom test cases using this scenarios language. So it really empowers you to, if there are parts of the data model that you want to touch more than just the profile tests, you want to do more than just making sure that a parameter is readable or writable, or maybe a vendor defined parameter does the right thing. Sometimes these scenario tests are the best way to really interact with the device and make sure that that functionality is working. And so the USP scenarios that would probably be another webinar, so I'm not going to get too deep into it, but you can check out the full documentation in the user guides for both USP and CWMP, which are right here. So with that, I am going to move over and see if we have any questions.
Thank you, Tucker. We do actually have a couple. You can jump right into those. I was going to try and throw some at you at first, but we're already running pretty solid. If you can bring the that resources slide back up, just so people can see. I wanted to talk to those really quick. Obviously, there were a bunch of people who, our initial questions, who weren't familiar at all with USP necessarily. So, we invite you to go and check that out at usp.technology. And there is links to the data models. The entire structure of everything you need is at usp.technology. And just a point of order. So TR-181 is used both by CWMP and USP, with some slight differences. Tucker touched on a couple of those, including the presence of commands and events in USP. And there's a couple of different things that way things work. Plus, there's some parameters that are required for CWMP and some that are required for USP, just for like the actual protocols to function, that are not included in both. So when Broadband Forum publishes the TR-181, we publish two versions. There's USP data models and CWMP data models, and those are the two locations you can get to. All right. What do we got so far?
Okay. Let's see. So someone asks, do you have test profiles for search paths in USP, or is it maybe covered by the USP functional tests? And that's a great question. So yes and no. No, there are no profile tests for search paths. However, that is part of the USP conformance test. So the very first section of the USP conformance, I don't have the test number memorized, but if you ran the first section of the USP conformance tests, there are several search path related test cases in there that would verify that functionality. So yes, we do have coverage there. It's not, you can't use a search path. Those tests have very specific parameters cooked into them. So we're going to be using a search path for, I think it's boot parameters. But like I said, using USP scenarios, you could, in theory, test search paths for anything in your data model if you wanted to. Let's see.
I'll grab one really quick. It was a question about having a license to share CDRouter test results. Whether the company you're sharing with needs a license in order to fully consume them and read them in the expected way. The answer is yes, right? But that's good, because when you output a full set of CDRouter results to someone else, you not only give them the results, but you can also give them all of the tests that you ran, the full package that you built, and the configuration, and then they can load that up and run that themselves, which is really nice. The way to output it without to somebody who does not have CDRouter is to use the printable report, which basically makes like a test summary that you can turn into a PDF or whatever you want to share with them.
So here's another question, which is about USP testing and specifically using the MQTT MTP. And so this person's curious if it's possible to use their own MQTT infrastructure, and if CDRouter could run in that configuration. And the answer is unfortunately not. CDRouter, our controller is basically very closely coupled with our MQTT broker. And that's because, we need to be able to send sort of the suspicious or malformed MQTT records to the agent to get, to verify that all of that sort of error handling functionality exists. So unfortunately, the only way to run MQTT over USP or USP over MQTT is using CDRouter's built-in broker. Good question, though. There's another question here that says, are there some standard parameters whose values do not exactly match the standard value? So you get a fail when you do a get parameter value. Is there a way to update the expected values in the config file? And so what I'm guessing is going on here is maybe, for example, a parameter value is longer than expected, or perhaps it's outside, it's an enum value and the value is outside of the enum defined by the data model. Using those modify parameters test vars, so USP modify parameters for USP and CWMP modify parameters for CWMP, you should be able to update the syntax for those standard parameters that are failing and get them to pass if you actually have sort of an updated syntax, if you've extended that parameter to either have new enum values or have an extended range or something along those lines. So you should be able to modify the syntax there. The user guide would probably be a good place to start when looking at sort of how to make some of those changes. That's a very good question.
There was a quick question about sharing the RDK profile test details, and I'm pretty sure, correct me if I'm wrong, Tucker, that's the RDK profile tests are just named. They're a named test module, right?
Yep. Yeah. The probably the easiest way, because honestly, off the top of my head, I don't really have the details. The easiest way to check them out is they're something that's shipped with CDRouter. So you could go and look at the documentation up on our support site for those test modules. Yeah, they should have RDK in the name. They're featured both under the TR-069 and USP add-on. There's a module for each add-on. So that's hopefully that provides enough information. So one question here is, how can you test the USP agent in relation to multiple controllers in that use case, including the authentication of agent and controller, and also the support for usage of different MTPs? Okay, so there's a couple different parts of that question. Right now, we have, I guess I'll start at the maximal complexity here and bring it back down to where we actually have support. So we don't have any support at the moment for multiple controllers using different MTPs, talking to one controller over WebSockets and another controller over MQTT. What we do have are several tests within the USP conformance test plan that will add a secondary controller using whatever the MTP is that you've configured, and make sure that part of the data model works. So, what happens when you add a controller or an MQTT connection? Does the device reach out and connect to the MQTT broker, and then, subsequently can send messages to this secondary controller that you've got configured? things like that. So that functionality does already exist. It is also possible, you know, and it's more of a, if you really wanted to, you could use something like ICS, which is CDRouter's internet connection sharing, and that's another add-on that would allow your agent to connect to a real controller, maybe in your lab or something, if you wanted to have some other controller connection active, which in theory could be using a different MTP than the one you've configured for testing. But that's sort of off the rails, you know, in terms of use cases and testing multiple controllers, and actually verifying that works within test cases. We only have support for using the same MTP, and there's a handful of tests within CDRouter's USP conformance test plan that cover that. That's a really good question, though.
It's like one of the benefits yet unfortunate consequences of having repeatable testing is that it has to be a very controlled environment. Yeah. I wanted to touch really quickly because I realized that there might have been an expectation about some information we give about TR-181 that we wouldn't have had time to get to. I assume that the person asking this question is asking about what's different from TR-98. And what I will say is that TR-181 has been around for 13 years now. And all new functionality that has been developed for TR-69 and obviously for USP has only been published in TR-181 from here on out. So anything, especially in the last few releases, you know, everything to do with Wi-Fi Alliance data elements and IPv6 itself. And there's just so much more functionality in 181, and it is structured way better than TR-98 ever was. On top of that, TR-98 has been officially deprecated and might be obsoleted very soon, you know, depending on how certain decisions go. So that is what I will say about the difference between TR-98 and TR-181.
There is another question here that says, can we alter or add parameters / syntax in CDRouter's auto profile? Yes. Well, yes and no, right? So the auto profile itself, when you're running a package, CDRouter will sort of profile your device and say, okay, here's what I think the device's data model is, and so I'm going to run with that. But as a part of that process now, it will spit out that XML file to the log directory. And that is a perfectly well-formed BBF, you know, XML format for a data model that you can feed back into CDRouter as a custom data model. So what I would suggest people do is you generate that file using that CDRouter auto profile mode, right? And then you download the XML file, look through it, and you can absolutely add parameters to it, you know, fill in any sort of syntax, correct any mistakes that, you know, maybe your device reported that a device or a parameter was actually an unsigned int when it's really an int, or vice versa. You can correct any mistakes there, and then upload that profile back onto a CDRouter system and configure that as a custom profile. And then you can sort of, you know, through that, fill in the gaps. So yes, you absolutely can use CDRouter's auto profile, create an XML file that you can then further refine and feed back into CDRouter to enhance your testing that way. So that's a very good question.
And that is actually what it's designed for, right? And
absolutely,
not for nothing, and not saying that we would recommend doing this, but you know, that is a valid broadband form data model that we're producing, right?
Oh yeah, 100%.
Yeah. So if you wanted to use that for any other purposes, you'd be able to do that as well.
Mm-hmm. Yeah, I mean, like I said, that feature was essentially born out of users coming to us and saying, we have this data model that it's sort of, we implement a handful of these parameters or these profiles, but not all of them. And we have a bunch of vendors, and we want to do the whole custom profile testing thing, but we have a model in the format, we don't know where to begin because we have like a, 3,000 parameter, thing like that, to help people in that situation that, getting a good start point for creating their own data model.
All right. Well, thank you very much, Tucker. That was excellent. I think this is going to be nice and consumable later, which is the question we always get. We are going to turn this into a video. We will package up the slides, and I will send that out to everybody who has registered for the webinar. And it will be up on our website soon for you to watch at your leisure or share with other people that you need. And I think it will probably make an appearance in the overall CDRouter training series page, which I actually did forget to put in the resources. I apologize. If you go to qakfa.com and go to /CDRouter -training, you'll find a whole bunch of videos from Brad, and then a list of all of our webinars that touch on things like this. All right. Thank you, everybody, for attending, and we hope to see you at the next one. Thanks a lot, Tucker.
Thanks, everyone. Yeah, thank you.